So perhaps you have made the prediction that this derivative here, red, this is 4 times x to the third plus 3 raised to the third, right? So what I did is I took this power and brought it down, reduced the power by 1, times the derivative of what's inside. So this is 3x squared. And this inside-outside, well, let's just simplify that. That's not simplify it, but make it a little bit easier to read. 12x squared times x cubed plus 3 to the third. There's this inside-outside rule that's essentially the chain rule. And so what we did was we took the derivative of the entire function with respect to what's inside, and then we took the derivative of what's inside. And why does this make sense in terms of, I'm going to talk about dimensional analysis. So this is dimensional analysis. Okay, so this is like physics is a big thing that asks for dimensional analysis. Well, when we take the derivative of this big thing, so d dx of x cubed plus 3 raised to the fourth. So we're finding that derivative. If we look at this as the derivative with respect to x, the derivative with respect to x to the third plus 3 of x to the third plus 3 to the fourth times the derivative of x to the third plus 3 over the with respect to x. This is essentially what we're doing. This right here, x to the third plus 3, just think of this as a this is the derivative of banana to the fourth with respect to banana. And I like to think of it that way because really we when we do this, if we were to write this as let's write this as u. So u is equal to x to the third plus 3. The derivative of u to the fourth with respect to u, and then we do this times derivative of x squared plus 3 with respect to x, whoops, x to the third plus 3. When we think of it this way, and we will think about it this way when we do integration, which comes after derivatives. When we think of it this way, it's kind of let me underline this u with yellow. You know, like the derivative of u with respect to u to the fourth with respect to u. Well, that's easy. That's u to the third times 4. And this one is easy. This is just the power rule. So we have times 3x squared, well, plus 0. Well, we just said that that here u is equal to x to the third plus 3. So what is that? Because we just put u back in there. 4 times x to the third plus 3 to the third. So I'm just putting u back in there. And we have times 3x squared. So why is this, and this is 12x squared times x to the third plus 3 cubed, right? Which is just what we have up there. So why does this make sense? Let's go back up to here. Let's go back up to this line, and let's think about in terms of dimensional analysis. It's not perfectly legal to do what I'm about to do, so I'm going to do it and then quickly undo it. But when you think about this multiplication right here, we have a fraction multiplied by a fraction, and you see some like terms canceling, right? Do you see this? this term right here, I should do that in a different color. This term right here and this term right here, they're going to cancel. And we're left with derivative of x to the third plus 3 to the fourth divided by dx, which is what we're doing over here, right? We're taking that derivative. So the reason this should kind of make sense is that in terms of dimensions, right? So let me just talk in terms of dimensions. If we have, and this is just a very, very simplistic example. If we have miles per hour, right? If we said something's traveling at 40 miles per hour, should be like this, miles per hour, and it travels for 2 hours. And we want to know how far it goes. We would cancel these hours. Like hours divided by hours is 1, and we'd be left with 80. So that's the dimensional analysis part of the derivative. Taking a derivative with the chain rule. And we'll get in a lot of practice of talking about what this u is, what the composite function is, and if it's a composite, if it's a function of a function of a function, the dimensional analysis will help us get through it. Okay, so I hope that wasn't terribly confusing, but we'll get lots of practice on this.